Hello everyone, I am santhosh.dk, Assistant Professor, Department of Computer Science and Engineering, Canara Engineering College, Mangaluru. I am going to discuss data structures with C laboratory course with subject code 18CSL38. In this course, we will be conducting 12 experiments and any study material regarding this course is available on my website. Along with that, you'll also get a study material on C language and varieties of other subjects which I handle. Also, you'll get the opportunity to use online compiler in my website. You can run the code on the go. Before solving the experiments, better to see the prerequisites from the C language which are most used in the experiments. Let's see one by one. Prerequisites are the first one. We are going to use decision making statements. Decision making statements are going to work based on some conditions. So in this we are going to use all these decision in this lab we are going to use all these decision making statements. It might be only if, or it might be a combination of if and else, or it might be a more combination of if else and or else it might be a switch statement. The if statement works based on some condition. The condition is true, then the true part of that will be executed. If the condition is false, then the false part of that will be executed. So for these conditions should be embedded with if and else. So like that we may use nested if in some of the programs where we are going to have some more conditions or with a if and a more added condition with else if. So then we are going to use switch statement. The switch statement is highly used over here because most of the programs are asked with a menu driven programming. So menu driven programming can be achieved in C language with character based input is achieved with the help of switch statement, where we are going to list out the menu options and you have to choose. Based on your choice, the switch statement is going to execute that particular part of the code. And switch statement has the beautiful thing that it can execute only the respective code. It will ignore the rest all the cases. So for that, switch works with a variable called choice, where the choice should be either a integer number or it can be a character. It cannot be a floating or it cannot be any other data type variable. It should be only, please remember, it should be only integer number or it should be a character. So after that, going with a switch, you will be having cases to handle. So individual cases will be handled. So here whatever you have taken as a choice, it might be, if it is integer it will be 1 2 3 like that, or if it is a character it should be in a single quote, and the rest all the code will be executed with respect to case 1 over here, or you may have a function call anything over here. And after every cases it's mandatory to break the case, otherwise it will continue with the other cases. For that it's mandatory you have to break the case. And other beauty of this switch statement is it is going to provide you a default statement. The default statement will be executed when none of these cases are going to execute. So this is used to achieve many driven program in our uh, course, and also in some we are going to use this for generating some priority numbers. And anything you want to learn on these things in detail, you are free to visit my site, where C programming for problem solving subject, where in detail discussion with syntax and programs have been discussed. The second statement which is used highly in this course is looping statements, where based on the situation we may use any of these loops, but the common thing about these loops are these are repetitive statements, and which should contain these three parts in any of the place. For example, if I take a while loop, the loop should be initialized so that it should continue, it should begin. And before begin, we have to test whether the loop condition matches. If the condition matches, this loop will be repeated until what that condition fails. How it is going to fail the condition based on the loop update. So these three are the key terms with respect to these looping statements. The looping statements If I take for loop, the for loop will be having the same loop initialization, test condition, update in a single line. And if it comes to do while, the do is a keyword which begins over here. Loop initialization is common as like while, and only the while test condition will come in the bottom part, and you have to terminate that. Based on the requirement, you can go with any of the looping statements. Why I am telling about looping statement is most of the data structures programs are coded using these looping statements. Next is conditional statements. The conditional statements are going to stop or continue your execution inside the loop. Take an example that you are searching for an element out of 10 elements, and you have got, I will just number them, just random numbers 1 to 10. I'm searching for 2. Take up. So I got 2 on the second position itself. I need not to find until 10. So what I have to do, once after I found this, I have to stop continuing this process. I need not to repeat that loop. To do that, you are going to use break statement. Yes, on this condition, something I don't want, I just ignore this and I let me continue the rest of the code. For example, here something is happened and some more statements are there. I don't want these statements to work on based on some condition. For example, if I encounter a even number, I need not to execute this. If it is an odd number, then only I have to execute this. If that is the case, you can go with a continue statement. And coming to the next, we are going to discuss the definition of data structure. A data structure is a particular way of organizing data in a computer so that it can be used effectively. So, by the definition, we can understand that a data structure deals with the storing and retrieval of a data. In C, we are having mainly two categories of data structures. One is primitive data structure and another one is non-primitive data structure. Non-primitive data structure, this we have learned from C language that there are something called inbuilt data types, predefined data types. These are called as primitive data structures. The primitive data structures are integer, float, character and boolean. These are the main building blocks of these data structures. And coming to the non-primitive data structures, we are having again subcategories called linear data structure and non-linear data structure. On linear data structure, we are having arrays. Array is the derived data type which is from the any of these primitive data structures. And next we are having linked list, stacks, queues, trees and graphs. In this course, we are going to code for all these, and we are going to use some of these data structures, and we are going to achieve some applications using these data structures. So this is what we are going to do in this laboratory. We'll be coding for all these, and we are going to analyze how they are going to work. Along with that, we are going to get to know what are the applications in the real world with respect to computer, how these data structures are going to play a key role in the computer programming. First, we'll see arrays. What is array? Array is a collection of elements of same data type. See, whenever we are defining, this is the main thing we have to remember with respect to arrays, because it's a collection of same data type is also mandatory. Don't forget to specify that. The same definition, a collection of elements of different data type will result in a structure. That's why I'm telling you same is very important over here. And here in array, the elements are stored sequentially, one after another in the memory. And as I said in the before previous slide itself, that array is a derived data type. And any element in the array should be accessed with the help of array name and the position. For example, if I'm having an array A, and if I'm going to have n number of elements over there, so for example, I want to access the first element, then I have to take a name of the array and I have to specify the position. The combination of these two will give me the respective element inside that array. And each value in array referenced as with a single name, as we have seen, and which is the name of the array, and the position whatever I specified here, Some people may call them as subscript, some people may call it as an index. I may use different terms while explaining, but don't get confused. If I'm calling subscript, index, position, all three are same. The subscript, whatever I have specified, should be always a integer number irrespective of what type of array it is. For example, if the array is character array, then the subscript should always a integer. If it is a floating point array, then also it should be a integer. Irrespective of the type of the array, you need not to worry, you need not to change these subscripts. The array can be any type, but the subscript should be always a complete number. Please remember that. And all these enclosed within the square bracket. There are two types of arrays. One is single dimensional array and other one is multi-dimensional array. Again, based on the author, they may tell there are three types also: single dimensional, two dimensional and multi-dimensional. But I consider there are only two types: single dimensional and multi-dimensional, because multi-dimensional is nothing but more than one dimension, so it can be two or three, whatever. So in this example, in this we will see single dimensional array. The single dimensional array is called as linear list. Also it is called as a vector. So where it's going to have elements of same type and all the elements are stored continuously inside the memory. Let's see how to declare a single dimensional array. For array, it is a collection. We have said it's a collection. To tell what type of collection, you should specify the data type. The next one is the array name. In the previous slide, I have shown you array name is A. You have to take up a name over here. Please remember the rules for declaring a variable or identifier in the C language. They are mandatory when you are going to take a name of your own inside the program. Don't forget those rules. If you are going to violate those rules, it's going to be an error. So here we are going to take a name based on those rules, and next we are going to tell how many elements are required for that array. So the data type can be user defined data type or it can be a predefined data type. So I call it as user defined, structure, union, or linked list, etc., or else predefined integer, float, or character are the highly used data types. And array name, as I said, it should be taken by following the rules of the identifier, and array size is a fixed size, and please remember it should be a positive number. It should not be a negative number, or it should not be a fractional numbers. And let's see the example. I'm going to declare an array called A of size 5 and of type integer. So in ANSYS, int means 4 bytes, right? 4 bytes will be allocated. So whenever I am going to take 4 bytes for individual elements, here I am having a collection of elements, and as I can show you, even though I say there are 5 elements in my array, but actually it is going to give you 6 elements. Why? Because in the computer the memory address always starts with a 0, so we will get a location from 0 to 5. Now how many elements are there actually allocated for me? 0 to 5. If you are going to directly take only 5, then so we are going to use till here. The last one will be ignored, or else you can start from here, you can use till 5. You can ignore any one of the last, either it is a 0 or it is the 5th one. My suggestion is, whenever you are programming, don't waste the memory which is allocated for you, because if you want to become a good programmer, you should also use the resources properly. Should not waste the resources. So now let's see how many bytes will be allocated. Actually, if I consider I am having only 5 elements. We'll take up a simple thing like I'll start from 1 to 5. I'll ignore this part right now. So I'll take up 1 to 5 are the elements available for me. So integer means 4 bytes. How many elements? 5 elements. Totally how many bytes will be allocated? 20 bytes will be allocated for variable A of type integer, is a array. As I said before, if you want to access any of the element over here, you have to have a two combination. One is the array name and the other one is the position or index or subscript. These are all the things you should remember with respect to accessing an array element. Next, we'll see how to read the values from the keyboard so that we can store those values inside the array. Here I consider from 0 to 5 irrespective of only considering 5 elements. So for that, what I do is, as I said you before, I'm going to use looping statements, because why I have to use looping statements over here is I'm going to do the similar task how many times? 5 times. It means 6 times I have used the smaller than or equal to, it means 6 times I'm doing the same task to fill the values inside this array. So for that, rather than writing this statement 6 times, what I do here is I'm going to use the loop, which is going to reduce my code length. And here what I did is I started with 0, that's why I'm going to show you I means it's going to point to the index. Next, I'm going to check for a condition I is smaller than or equal to 5. It means it will range, I can range from 0 to 5. And next, it's the updation. This is what I spoke in the previous slides. Loop initialization, loop condition, loop updation. This condition is true, 0 is smaller than or equal to 5. Let me in. So now what I am going to do is, scanf is the formatted input statement which you have studied from C language, that there are two types of input output statements, formatted and unformatted. Scanf goes to the formatted input statement where I'm going to read the %d, means I'm going to read the integer value, decimal value, and I'm going to store the values on the respective location. How to get the location? The ampersand is the one which is going to give me the memory address of this A and I, combination of A and I, because I'm not going to show you what are the memory addresses. I'm knowing only with the name and positions, but internally it works with the address. That's why to locate the address I'm going to use ampersand. Next, I'm going to get A of I. Initially A is fixed. This is what is given for A, this complete part. This complete part is given for A. Next is I may vary from 0 to 5. So when initially it is 0, consider I have given an input 10. I have entered through keyboard 10. So 10 will be stored over here. Next I will be updated to 1. I was initially 0. So 0 plus 1, I plus plus is increment. So it will be updated to 1. So now I is pointing to this location. Next I have entered 20. So 20 is stored over here. Similarly, it goes on when I is 5. 5 is smaller than or equal to 5. Still it is true, and it will allow me to read the value, and the value I have entered is 60. It's stored over there. And now I is incremented to 6. 6 is smaller than or equal to 5 is false. Then it stopped reading, and I have 10 to 60 all these elements on my array. Next, we'll see how to display the elements. See guys, very simple thing with respect to reading and displaying. For reading, we are going to use a formatted input statement scanf. For displaying, we are going to use, sorry, it is printf. So we are going to use printf, formatted input statement printf. Now here what we are going to do here is we will get the values. Rather than storing the values, we are going to retrieve the values and we are going to display. Only the difference over here is the scanf is changed to printf, and also we have added some space because it is formatted output statement. I am free to use whatever I want inside those double quotes. So I'm going to give space between the first element and the second element by giving a /t. Then I'm getting the value of A and position, and I'm going to replace that value, whatever the value. If it is A of 0, then 10 will be displayed here. If it is A of 4, then 50 will be displayed over here. And the other changes what I made from the previous reading and displaying is, one thing is printf, and second thing is I have added /t. The other one you can notice that I have changed ampersand. I have removed the ampersand, because if you are going to add ampersand over there, I told you ampersand is meant for retrieving the memory address. If you are going to add the ampersand over there, you are going to get the memory address rather than the value of that particular memory location. because I am interested right now in value rather than the address. Next, we will see functions. What is function? Function is a block of code to perform specific task. It means the given task is divided into n number of small tasks, and each individual small task can be achieved with the help of function in a program. So if you take up any function, should have these three characteristics. It should have a declaration, it should have a function call, and it should have the function body, definition or implementation. We may call in different words, but all are same. What is function declaration is? Actually, the function declaration is a skeleton which is going to tell like this function, it's going to tell the compiler like this type of function is going to come in the future, and whenever you need it, you are going to call that function using a function call. And when it is called, of course it should have something to do. That is what we call it as a function body or definition or implementation. What is the advantage of functions? There are mainly three advantages I can tell. One is the reusability. You want to do some task repeatedly, 1,000 times, crore times, million times, billion times. What you have to do then? Rather than writing that statement million or billion time, what I can do, I will write the same statement once and I will call it billion times. So where I'm going to reduce the code length rather than writing the same code repeatedly throughout my program. That is the one beauty of function. The other one is easy to debug. Yes, I know this task is done by this particular function. For example, addition is a function name. The addition is done by a function name called add, and the addition answer is not proper, is having error, like it's not giving a correct answer, then you need not to worry about the rest all other function. Only you have to target on the function add, where you have to go and check whether your addition logic is proper. Through this we can debug easily using the modular programming. The modular programming is nothing but the programming language which supports function concept, module concept. The given task is divided into a number of tasks. And third one is build library. With the help of these functions, you can have your own library where each function is meant for respective task. And if you are going to code for the same in the future, rather than coding the same functions, you can use them which you have already coded, just like you are using printf and scanf functions. Printf and scanf are the inbuilt functions, but you are free to create your own user defined functions. The first part of function is function declaration. Every C function in C should be declared before they are used. Why it has to be declared before they are used? Because it's going to tell the compiler that what is the function name, what type of arguments are being passed to that function, and what it is going to return. So the syntax for giving a function declaration is, first you have to specify what type of value it's going to return. If you are telling I don't return anything, my function will not return anything, then no need to worry. So make it as a void, but it is mandatory, at least you have to tell it's not going to return anything with the help of void. And function name, the function name again should be taken by following the rules of identifiers or variable. So even though you say it's not a variable, but it's the user defined name, any user defined name in program has to be followed the rules. So create is the one which I have taken by following the rules of the identifier, and this is the function name, and these two are mandatory. And coming to the formal parameters, if you are willing to pass and cache the parameters through your function, then you are free to go with a parameter list over here, and it is optional. You need not to worry if you don't think that I am going to pass and I am going to retrieve anything from the function. So you have to specify it as a null. It means don't specify anything over there, let it be empty. And if you are not returning anything, please remember you have to write at least void. And next we'll see how to make a function call. The function call will be made by taking the function name. So, and if you are passing, as I said, parameters are optional. If you are passing any parameters, then only you can have a formal parameters over there. If you are not having any actual parameters, then you need not to worry about the formal parameters. So I have written a simple function, the create, and where I am not passing and I am not receiving any parameters to that function. That's why I left it empty, and this is the one optional. And here I am making a function call to create. Next, how the function definition should be, or how the function implementation should be, or it can be a body. So it is same as like return type, how we have written in the declaration, both should match, and the same function name what you have written in the declaration, call, and definition. Please remember, C is also case sensitive language. Don't play with the cases. It's better to go with all with the small cases whenever it is required to use capital characters, so you can use, but please remember whenever you made a changes and what all the parameters we have specified, if you want you can specify, so those will be on the list with the variable names. But in this example I'm not going to take any parameters. And see, in the previous both I have used semicolon, but here no need to use this semicolon because I'm continuing it and I'm writing a body with the help of flower bracket set. Next, if you require any local declaration, it means you want some temporary variable inside that function, you are free to declare immediately once you enter inside the function. And after that you can have n number of statements to compute the task, whatever the task, whatever the function is meant for. Then finally once you done, you return the value. You return the value, the answer back to the calling function. Let me take an example. We were going with a create, and create is a function. Here we are used to create an array. So create is a function. I did not declare any variables here. Assumption is all these variables are already declared. And here I am going to ask, enter the size of the array elements. How many elements you want? As I said, 5, 6. Like that, if you want to specify, first you ask the value of it and store it in a n. Then enter the elements of the array one by one. So next what you have to do, use the loop as we have seen in the previous discussion, and this condition is changed right now. So the condition was there, I is smaller than or equal to 5. Now I have generalized that 5, it can be 5 or it can be 10 or it can be anything. That's why I'm taking a variable n, and I'm not going to give smaller than or equal to. What is the happen when you are going to give smaller than or equal to is, it's going to read if it is a 5 6 elements. I don't want to read 6 elements. When I say it is a 5 element, it's better to read only 5 elements. That's why I'm going to remove smaller than or equal to. Then I'm going to update, and it's going to read all the elements to that array. This is the function to create an array. And all the experiments in this course are referred from these textbooks. If you are getting a copy of this, it's well and good. You can refer any concepts, any conditions, or any theoretical things, any examples or more examples from these books. The IDE code block with a version 13.12 is used in this course to explain or demonstrate the programs. So if you want to download, you can visit this site, and the thing is, I used 13.12. There might be a version of 17 or 18 right now, or it might be higher than that. The why I opted for 13.12 is for the beginners. When you are going to install, if you are going with a lower version like this 13.12, then it's going to come up with a GCC library. Otherwise, if you are going with the higher versions, it's your task to get the library, GCC library, and add it additional to the code block. So to avoid those confusions, I prefer going with 13.12 version, and all the experiments in this lab are executed using this open source code block cross platform IDE. You are also free to use this.